Hello everyone, my name is Sophia and I'm joined here by
Krishna, Reddy.
And we're just going to be conducting our second interview with professors. So just to get us started, I'll go ahead and ask you. You have studied and worked across 2 continents. How have those experiences shaped the way you view the field of civil and environmental engineering today?
That's a good question. So I came from India 30 years ago. And then that time in India, it's, infrastructure and environmental systems were just started to develop. And when I came here, I saw, a lot of infrastructure, environmental systems are built up. It's nice to see that contrast. Now situation is different. In India, they are starting to develop new environmental systems, infrastructure systems. Whereas in the US, we have aged infrastructure and we have environmental systems. The infrastructure and environmental systems are not designed from the lens of sustainability and resiliency. So a lot of things are going on in the US to retrofit, whereas in India, they are starting to develop. So it will be nice to have them start from this. Even they're starting from scratch, they can incorporate all the sustainability and resiliency things. Whereas in the US, it's hard when you built it and then retrofitting, it's hard. So I think I could see those contrasts very well and appreciate, how things could be done more sustainable and resilient way. Yeah.
I definitely noticed that in the United States, and it's going to be interesting to see how new developments are going to be made going forward.
Mm-hmm.
So what actually originally drew you to geotechnical and geo-environmental engineering, and what made you stick with it throughout all these years?
Well, in undergraduate like you, I was a civil engineering student. My favorite subject was structural engineering, but then I realized that structural engineering is like a very well established, with all the methods and everything. But geotechnical engineering is a little bit challenging because every project is a new project because site conditions at every location is different. So you cannot really have a standard template, standard design that can be used anywhere. So you really have to look at the soil conditions and design it accordingly. So I like that kind of challenge. Every project looking from its own perspective rather than using a cookbook solution. So that makes me, very interested. And also in geotechnical engineering, it's very important to see how things are built. And that kind of experiences are very important in designing the, geotechnical system. So it's very fascinating. As I said, every project is unique. And I mean, some people like it, some people don't like it. I like excitement on every project, but if you don't want to have that kind of challenge, you want to have kind of a routine stuff, then you probably choose some other field. So I like excitement on every project. So geotechnical engineering offers those things, that opportunity.
So speaking of projects, I'm also curious to know what's one career milestone or like a project that you did that actually made you smile or you feel especially proud about?
I worked on a lot of projects, but going back, looking at it, the field investigations is something very important. I did my PhD, but I didn't have much experience working in the field. So when I went first day to the field, it's all like I'm a freshman. I think of working in the field, looking at what kind of soils that you have, what are the construction problems that you're going to have. So for me, I would not say it's a happy situation, but it's kind of depressing situation that, having PhD but not able to log the soil in the field. That is like a basic thing that one is expected when you're out in the field. So I always recall that field investigation, my first field investigation as my very memorable event. And then I tried to do a lot of field investigations, learn a lot of stuff. So field investigations is my favorite aspect.
Nice. Can you go a little bit into depth about what are these field investigations are like? Just like
In field investigations, whenever you have a project, first wherever you're building it, you know the site, right? So first you have to go there and find out what kind of soils you have. So you have to do the drilling, and then while drilling, you collect the samples. And as you collect the samples, if you are a field engineer, you have to classify or log the soils right away. And the soils that you get from the ground, varies quite a bit. Like every foot you have a different type of soil. Right. And when you are taught in school, you are given ideal soil, clean sand and clean clay. Mm-hmm. But when you go to the field, you have mixed soils. How do you describe that one? Right?
I don't know.
When I worked in school, in my lab classes and everything, they were giving pure sand and pure clay. Yeah. That was easy. But when you go to the field, you have a mixture of sand, clay, all kinds of stuff mixed up. Mm-hmm. What do you call that soil? You can't. So that's soil logging, collecting the soil samples, doing some field testing. Some testing you can only do in the field. Mm-hmm. Like vein shear tests, packer tests. Those are like a strength tests that we do, and slug tests, pump tests. Those are hydraulic conductors. So those are kind of things, that can be done only in the field, and doing them in the field is different than learning, through the textbooks in the classrooms and everything else. So I think that was my fascinating stuff.
Wow, that's super interesting. Yeah. I'm glad you could share that with us. So actually, what's something about landfills, soil, or remediation that most people wouldn't expect, but it fascinates you every time? I know we did talk about how it's not like the ideal soils that you see.
Yeah. No, I work with soils from civil engineering point of view, infrastructure point of view, like building on the soil, building with soil. Mm-hmm. But I also, from research point of view, I work with the soils in terms of environmental pollution control, or if the soils are contaminated, how you remediate them. If the groundwater is contaminated, how do you remediate them? And also using the soils for waste containment systems. So I work with landfills, soil, and remediation projects, and they're fascinating because all of them are related to protecting the public health. If the contamination is there, that could be exposed to people or the ecology, environment, and that could damage it. So my research is to look at how do you prevent the pollution from spreading and causing the problems to people. And how if it is already happening, then how do you fix it? Mm-hmm. So a lot of these things you are dealing with chemicals and microbes. So it's a very interesting aspects of how soils and chemicals and microbes are interacting. So understanding those fundamentals, I find it very fascinating. And if you can understand those fundamentals, then you can engineer solutions to solve the problems.
Right.
So they're all kind of interrelated. My main goal is to understand the fundamental, coupled processes that happen between the soils and chemicals and microbes, and then how we can, what you want to accomplish, right? Mm-hmm. You don't want the contamination to get through the soil. Then what kind of, how do you engineer that system? Or you want the contamination already in the soil, you want to take it out. How do you control the processes? So I like that approach, because a lot of times, just randomly going to the field and trying it is not going to work. Mm-hmm. So you need to understand the fundamentals. And once you understand the fundamentals, you can create the solutions to favor the conditions that you want, and then you can achieve robust solutions. So that's what I like about my research that deals with landfills, soil, and groundwater and remediation and all those things.
Yeah. So fascinating. Everything I'm hearing about it. I want to take this class. I mean, looking forward, I guess, what's one challenge or a question that you hope the next generation of civil engineers will be the ones to solve?
I think, even in my career in research and teaching, we keep on evolving. Some of the things that I taught 30 years ago, they are now redundant, or obsolete. Even research also is evolving so much. And even in our teaching, we have to adjust our curriculum, to teach, what are the new things that are coming up, right? Of course, fundamentals of soil mechanics, you cannot change that much, but like there's some elective courses, graduate courses, we always teach about new things. So what I would think about is all these emerging technologies, right? Like artificial intelligence, 3D printing, UAVs and all these things. I feel that, that would be the future for civil engineers to, be challenged with. They are not concepts, but now they are being implemented.
Right.
And how do you use those things for things that we want to accomplish?
A lot of evolving technologies.
Yeah, evolving technologies. So that's what I want civil engineering students to keep an eye on. And it's not in other fields, but there's a lot of potential for all of those emerging technologies to be used in civil engineering.
Yeah.
So that will be a great thing.
So speaking about students, what role do you think students play in driving innovation in your lab spaces?
Oh my God. I mean, students are main driving force for innovation in my lab, They're very sharp, they're very smart, they think innovatively. And so basically I challenge them with a problem and they want them to come up with a solution. And students suggest a lot of different things. And then we discuss and we pursue those things. So this generation of research students are much more talented than what I used to see in the past. So they want to use new technologies. So for example, I have a student who wants to work on, AI model, before, people were scared of working on AI models. So I think, it's the drive of the students, research students, wanting to do more emerging, innovative. That's what leading the research into, different level. Yeah.
Real interesting.
Yeah.
Thank you.
So students, I'm learning from the students.
Yeah.
And the students are the innovators,
Yeah.
I'm just kind of learning from them. And, it's fascinating, things that we are doing. Working with the biology, working with all these emerging technologies, that were not the norm in the past. But the students now, they are quite interested in doing it and they are capable of doing it,
What's one thing that you're working on right now that's really exciting?
We work on a lot of different things. I work on a lot of different things, but the one that we are working on now is making landfills as resource repositories. We think of landfills as we take the garbage and dump them there and then walk away. But actually, if you think about it, the things that we are dumping, those could be valuable resources in the future. So a lot of organic waste gets degraded and you get gas out of it. Gas can be converted into energy. And then when the waste is degrading, you create a heat and that could be captured and you can use for heating and cooling of the nearby houses. And at the end, when everything gets degraded, you could have inorganics, the metals and, all the things you can go and harvest them.
Yeah.
So what I'm trying to do is thinking landfills as not, dump yards, but rather, future repositories. So for that one, what we are doing is we are doing a lot of lab testing, field testing, and also the modeling. We are doing a lot of modeling, the physics, chemistry, biology-based models that we have developed. And then now, one of my students is developing an AI model through which you can kind of, how do you operate the landfill to maximize the resource recovery?
Yeah.
Because if you don't control it, you may be generating the excess gas that cannot be utilized or excess heat that cannot be utilized, or you're not generating enough. So how do you optimize, the whole landfill operation so that you can recover the resources? So it's going to be, really important for future when we run out of a lot of resources. So I find it very fascinating because we combine a lot of, the physics-based modeling, all our lab work, field work, and then developing the AI-based model. So I like I mean, I have other projects also, but those are all like, every project is very interesting for me.
Yeah.
Otherwise, I would not work on it. But this one is a really kind of looking differently, and with AI models, you can actually make it happen. Which was not possible before. So that's why I'm very excited about that project.
I'm excited too to see how this turns out. Any advice for students in the future?
I think you have to be open-minded. To learn the fundamentals. And then advanced courses. Just open up to other fields, because it's not a traditional thing. As I tell you, emerging technologies. You should be able to learn those things. Taking a course on AI. I mean, our department offers a lot of those technical electives. You can, don't have to stick to your conventional courses, but have the fundamentals in all basic fields of civil engineering, and then take some elective courses that are in the emerging fields. So, field is changing. It's not just the university setting, it's in the real world, things are changing.
That's sound advice. I will be personally taking that into account.
Sure.
Thank you so much. Okay. Thank you so much for giving us your time and for this interview. And thank you for everyone for watching. Keep an eye out for future interviews, and have a great day.